Right, well, good afternoon, everybody. Welcome back if you've been to one of our previous talks here at the Wiki. I'm going to go through the boring admin stuff again, I'm afraid. So we're not expecting to have a fire drill, so if you hear the fire alarm, it's probably a real one. So I exit through my air hostess, but exit through the entrance doors here and here, and up at the back. There are no life jackets on your seats. You should make sure that you switch off or mute your phones. That would be appreciated. And we'll have a roving mic at the end of the talk for any questions. So please wait until the microphone gets to you, and that way everyone can clearly hear your question. So our talk this afternoon, very pleased to welcome to the Wiki our speaker, Ilari Pätilä, for a talk about the last of the great auks. And I think perhaps the auks are one of my favourites of bird species. I'm not very good on birds, but they tend to be nice and sedentary, like the puffins and the razorbills and to less extent the guillemots. So it's an interesting range of birds, the auks. Now, Ilari is a master's student from the University of Helsinki in Finland, and he's finishing a master's thesis concerning the extinction of birds during the end of the last ice age. And he's primarily interested in extinct birds, including the great auk. And he's a member of the Paleontological Society of Finland. Is that right? The great auk was the only flightless seabird in the northern hemisphere, and the last one in Orkney was shot in Papa Westray in 1813. And he's going to tell us the story of the great auk and also some of the other magnificent seabirds from the prehistoric past, among them the ancient albatrosses whose fossils were discovered in Britain. So I'll pass you over now to Ilari and his presentation.
Yes. Yes. Welcome everyone to the presentation with the title "The Last of the Great Auks and Other Extinct Seabirds of the North Atlantic." This is a bit of a story about this picture. It's actually a bit interesting. This is it's a picture of Fogo Island in Newfoundland, Canada, and it's a statue of a great auk looking out to sea to one of the last colonies of the auk in Canada that was fully exterminated. And the great auk is, as mentioned, the only species of flightless seabird to make it to present day in the North Atlantic, especially in the Northern Hemisphere in general, but it has a very long and interesting story, and we need to start the story from somewhere, so let's start from the very beginning. First I'd like to introduce you to the geologic timescale. Well, this will help us acknowledge where we are or in the presentation, what geological period we're in, and currently we're situated in the late Jurassic period, about 150 million years ago, right there. And I'd like to introduce you to one remarkable little creature called Archaeopteryx. It's purported to be the very first bird, and it certainly is one of the first bird-like animals. There's a reconstruction of two individuals bickering over who gets to eat a lizard, and here is a specimen of the animal. It's the most famous specimen of the animal, called the Berlin specimen, and here's the skeleton. It's remarkably dinosaurian in shape. Here's the skull, the arms with little claws, the ribcage, and the vertebrae. Here's the pelvis, a long bony tail, like a reptile, and long feet with talons, much like a bird or a velociraptor kind of dinosaur. But in the outline of the animal, we can see feathers, big wing feathers, long tail feather, uneven, fluffy feathery pants like you would see on a white-tailed eagle, for example. And this was a remarkable discovery because it helped scientists to discover that birds evolved from reptiles and that evolution happens through intermediates. It's something of an in-between between a dinosaur or an animal and a bird, like we see today. And birds do evolve during the time of the dinosaurs. And as soon as they could, they went to sea. Here are some examples of such early seabirds about 80 million years ago, when North America was split in two by a great interior seaway. Most of Europe was an archipelago full of islands and seas of many kinds. And the birds in question are these two. These two look a bit like cormorants or shags, and those are actually called Hesperornis. They lived all throughout the northern hemisphere during the late Cretaceous. They were completely flightless, about between 1 meter and 2 meters long, and they were so flightless, in fact, that he only had some of the wing bones left. And their feet were a bit like grebe feet, which made them very good at swimming. We have also these seagull-like little birds. These are called Ichthyornis. They are about the size and shape of common gull, and very well adapted to live out in the sea. And their bones are found in marine deposit. And so we know that they lived out in the sea. They look very much like modern birds, but if you were to look at their bones more closely, you can see a few details that would throw you off in a modern bird. For example, they have teeth and a beak. And seagulls already give us trouble not having teeth. If they had teeth, they would do quite a bit more damage. So, yeah, but this large fellow in the middle looks bird-like. It even has fluffy things on it, which could be called feathers, but it is not a bird. It is a pterosaur, which were the first vertebrate animals to take flight, which evolved in the Triassic, about here. And it's very different from birds. Its wing is not made up of feathers, but of skin supported by one long finger, but it is bird-like. It even has hollow bird-like bones and a toothless bill, especially with this kind, Pteranodon, which has a name meaning wings, but no teeth. And not only were the skies dominated by reptiles, so were the sea. It's full of plesiosaurs and mosasaurs, all kinds of reptilian monstrosities, until about 66 million years ago, when this happened. A 10-kilometer wide asteroid hits the Earth right outside, in the Gulf of Mexico, near the Yucatan Peninsula, causing the 5th mass extinction, an event that kills off all the marine reptiles, all the pterosaurs, and all the dinosaurs. Well, they're not alien dinosaurs because birds are a kind of dinosaur related to things like velociraptors, and it could reasonably be called the single worst day in the history of life as we know it. But birds do survive, barely. Only one lineage of birds actually makes it. All the toothed varieties of bird go extinct, thank goodness for that. And so do all birds with more reptilian traits like claws on the wing. The only bird lineage that does survive is the Neoavi, which is the lineage of the modern birds. And right after the extinction event, they recover miraculously into incredible diversity. For reference, this image showcases all the variety of birds we know today. The extinction happens in this line. So all the lineages of birds start out in this, all modern lineages of birds start out in this moment and evolve quickly, rapidly, to take advantage of the new niche is left out by the disappearance of of the other dinosaurs and marine reptiles and other things that go extinct in the KBG mass extinction event, in an event that could be called the avian explosion, because all the modern avian lineage is evolved within 10 million years of the asteroid impact. It was a time of healing and a time to go absolutely insane when trying to carve out a niche of your own. And birds do that. And one of the things they do is they go out to the sea, and we'll be talking about some of the seabirds right now. The first we are going to discuss is this fellow. It's called Prof, and it looks a bit like a gull or a tern, but it's not. It's a relative of today's tropic birds. Sorry, the images is covering a bit of the text, but its fossils were found in the London clay formation, which is near London. We'll see more. We'll find more birds found in the London clay formation shortly. It lived about 50 million years ago, in that time frame when birds had diversified in the explosive manner that they did. But the birds that lived back then might not have been forms we'd recognize. For example, Prof was taking the niches of terns and gulls, but now tropic birds are very much their own things. They are plunged diving birds, much like gannets, but are smaller. This was more general. And here are some fossils. This is a skull. Here's the beak. Here is where the neck would attach to the skull. And here's the eye. Here's one of the limb bones. Here's the lower foot bone, or the tarsus, and these are some vertebrae. And this is really good preservation. Bird bones do not fossilize all that well, because bird bones are hollow, to help them take to the air and maintain flight. And it's also a part of their breathing system, which is great if you're trying to fly. Really not good when if you try to become a fossil. Also, so any bird bones we find are special. Well, if they're found in good shape, like these are, they're extra special. Well, and speaking of special, we have Mesilastega, which is one of the earliest gannets. It was discovered in the Nessel pit, which is a fossil site in Frankfurt, Germany, and it's a very special fossil site because as it preserves bones in incredible quality. As we can see from the skull, it's basically complete. Even preserves the mandible, the bill, the brain case, and the eye socket right here. And it preserves all kinds of things, from birds of all sorts to insects to leaves to frogs to mammals, including a relative of horses, which was about this tall. You could pick it up, and the environment of the Nessel pit was a rainforest, and the pit itself is a lake, which was in a volcanic crater, and the fossils were first discovered by miners looking for oil, because they preserved as oil shells, which is really interesting, and it kind of explains why these animals were preserved in such quality, because if there is a volcanic eruption in one of these lakes, toxic gases are released, small animals die, and they sink into the lake where they're not decomposed because there's no living things in the bottom of the lake feeding on dead matter. And there's also an interesting tidbit to that. The earliest gannet, which are all of them are seabirds today, lived in a lake, which quite a career path to say. It also lived about 50 million years ago or 40 million years ago, and back then the world was a lot warmer than it is today, given that there were rainforests in Germany back then. And in fact, the Arctic region about 50 million years ago had cypress swamps and alligators during an event called the PETM, or the Paleocene-Eocene thermal maximum. A lot of long terms for just saying that during a specific time of Earth history, the temperature of the Earth rose up by a couple of degrees during the course of a very short time. I wonder how that would be relevant to research today. Anyway, but quick tangent. And the periods of the Cenozoic, the period we're living in today, the age of mammals, are the Paleogene and the Neogene and the Quaternary, but they are also split further into shorter time frames known as epochs, and we have called the Paleocene, the Eocene, the Oligocene, the Miocene, the Pliocene, the Pleistocene, and the Holocene, which is the epoch we're living in today. Just as a frame of reference, because I'm going to need to explain things that happen within these shorter time frames. For example, we are going to move on to some truly monstrous birds, the Pelagornithids, which first appear 60 million years ago during the early Paleocene, and they go extinct 2 million years ago during the start of the Pleistocene, or the Ice Age, which means we as human beings just missed them. You think about time a bit different, and if you're a geologist, but they were, even though they're extinct now, they are incredibly successful animals. They had a global distribution, as their fossils have been found from New Zealand to the Americas to Africa to Asia to Europe, including fossil discoveries from the Enclave Formation again, which is situated in the Isle of Sheppey in Essex, which is quite close to home, actually. If you travel 50 million years ago to the place where Orkney was situated in today, you might have seen one of these flying around. And there are multiple kinds of these found. The one found in the London Clay in Essex is called Dassonis, but there are also genera with names like Pelagornis and Osteodontornis. But it's hard to think of a frame of reference to these guys. They are fully extinct. They have no close relatives living today. So what kinds of animals were these gigantic things? Well, I did say gigantic already, kind of a giveaway, but these apparently are distant relatives of ducks and geese. They are within the group, so now we know what kind of personality they might have had. Not a friendly one, probably. And interestingly, looking at both the skull reconstructions and this reconstruction of the head of one of these birds, they had quite the menacing face. They had long beaks lined with serrations that resemble teeth. They're not teeth, they are outgrowths of the bill, similar to what you might find in a merganser. And they are named some of these are named after these teeth, like Osteodontornis. It means bony toothed bird, which some suggest as a common name for these, though I would prefer to just call them pelagorns. And you might notice the long wings of the pelagorns, and it might remind you of something like a gannet or an albatross. And they were quite similar to albatrosses is in that they have these long wings. They have quite bulky bodies and large flipper feet. They were probably soaring for long distances, and we do find them all over the world. So they were traveling long distances, and probably swimming some of the time. And these long serrated bills were probably quite useful for catching fish or squid along the way. And a bit about the size. These might just be the largest birds to ever live in terms of wingspan, not weight. They're actually quite lightweight. The biggest Pelagorn might have weighed about 20 kilograms, but the wingspan is quite insane. The smaller ones have a wingspan of 2 meters. Small ones. The biggest one had a wingspan of about 7 meters. Now, for reference, this is a scale drawing of one of the is with part of the skeleton. To scale, we have the Andean condor and the wandering albatross. In terms of birds, you might be more familiar with the wingspan of that guy, of this guy, Pelagornithids, is more than 3 gannets put together. Quite big. So, and quite a bit larger than this fellow, Rupelornis, which is a relative of albatrosses, but it's a bit weird if you think about it in terms of modern birds you might see today. It lived during the Oligocene epoch, about 30 million years ago, and you might notice from this reconstruction that it has a long, narrow bill, maybe like an albatross or a shearwater, but it has long legs and big feet, a lot like a storm petrel. And the wings are actually short, or like a storm petrel or a shearwater. It's this mix and match of traits from different bird species. And you find this in really well-preserved fossils. They're a bit squished, they're flatter from top to bottom, but to give you an idea, here's a skull, bless you, from top to bottom. Here's the bill, here's the skull. This is a humerus. Here's a leg bone, and fossils of these have been found in Germany and Belgium in fossil formations known as Lagerstätte. It's a German word for a storage facility, and it simply means a fossil site that preserves fossils either really well or quite a bit of them, and places. And in fact, the Nestle pit is a Lagerstätte as well. And so because they preserve birds, both a lot of them and in good quality, they are really important in discovering more about bird evolution. In fact, here is a more bizarre example. This is called Bambolinetta, which was discovered in Monte Bamboli in Italy during the late 1800s, and it lived during the end of the Miocene in about 10 million years ago. And when it was first described, it was found that it was a duck, but it was named Anas lignitifila, which is basically the researchers of this which discovered this animal were saying, okay, it's a duck. Okay, anything special about it? It's a duck. Nothing more, nothing less. Until the fossil was revisited in 2014 by Goldmeyer and Paviamarco, which discovered that this is no normal, ordinary, run-of-the-mill duck. This duck was strange. It's a marine duck which lived in Italy during a time when Italy was made up of a bunch of archipelagos. It was in fact if you know anything about islands promote strangeness in evolution, especially if if islands are isolated for a long time and have no native mammalian land predators. And studying the wing, they found that it was small, probably could not support such a bird in flight, but the limb was muscular. It had had really noticeable muscle attachments. In fact, this is the humerus, the upper arm bone. It's really stout out, and so is the rest of the wing. Bless you. And here's the skull with the orbit, the brain case, and here's the start of the duck's bill. And studying the humerus and the rest of the wing and the rest of the animal, the researchers concluded that this was an unusual kind of duck that was flightless and swam with those wings a bit like a penguin or, a great auk. And it lived during a really interesting period of time, which doesn't have a name, but during this time was an event that could be called the Neogene seabird radiation. Doesn't have an official name, so won't trademark it just yet, but during the Neogene, especially during the end of the Miocene and the Pliocene, so between 10 to 5 million years ago, most modern seabird lineages diversify rapidly and noticeably quickly, and we don't know why. This image from Obio et al. Showcases the family tree of shearwater as from all over the world, and they see correlations between different events, like the completion of the ice cap in Antarctica and the Zanclean flood, which is when the Mediterranean, which had been closed for a couple of million years, opens up again, and seawater floods in. That was a time to be alive, wasn't it? This kind of rapid radiation and speciation during this time of the late Neogene is observed in shearwaters, but also in albatrosses and penguins. And if we find more material, it could be spread out to other seabird lineages, like fulmars and auks. In fact, the Miocene is when we start to find all sorts of stray seabirds, both fully extinct and modern, that we could see today. One of them is this lovely fellow. This is Phibastria anglica. It's an albatross, just a normal albatross, except that the fossils of this albatross were discovered in Suffolk, in Foxhole. And they were first described by then famed paleontologist Richard Lydecker in 1891 as Diomedea anglica. It was later reworked because Diomedea now only includes the large white albatrosses of the southern hemisphere. It was then reworked into Phibastria, which is this genus that includes the northern hemisphere albatrosses, which now live in the Pacific. But this one lived in the North Atlantic. Its fossils have been discovered in Suffolk. That's why it's named Phibastria anglica, the albatross of England. And they've also been discovered in Morocco. And it was a bit larger than North Pacific albatrosses, but if you'd see one alive today, which is like an albatross, what's that you might see in the Northern Hemisphere, maybe a short-tailed albatross, or a lazy albatross. And it becomes extinct during the start of the Ice Age, which is about 1.5 to 2 million years ago. We don't exactly know why. It could be because of it's growing for the first time, which cuts off oceanic highways for albatrosses to travel from the Pacific to the Atlantic, and vice versa. So it could also be that there was a loss of proper habitat. That's all that had predators like Arctic foxes and polar bears now had the opportunity to travel to lots of these islands and start eating birds that would have been defenseless against predators. We just don't know. Here are some of the discoveries. This is of the albatross. This is the lower leg bone, the tarsal metatarsus. Here's one of the lower arm bones the ulna, which is quite long in albatrosses, as one might expect from something with quite long wings. And we'll continue with albatrosses with peculiar discovery. This is the modern short-tailed albatross. It's still alive for now, because it's in danger. They almost became extinct during the 50s due to overharvesting for feathers and meat. And they now only breed on a couple of islands around Japan. They are recovering, but slowly, because albatrosses are large birds that breed slowly. Now, what's interesting is the same species was around during the last ice age, which is in the Atlantic, because we discovered that on the island of Bermuda there were colonies of these albatrosses, but they were wiped out for unknown reasons around 400,000 years ago. One reason why they became extinct from Bermuda could be that is that when sea level rose, the lowlands of the island were fully wiped out. Albatrosses need wide open space of land to both nest in and take flight, because taking flight isn't easy for an albatross. In fact, if you watch videos of albatrosses taking off, you will see them spread their wings quite wide, flapping them vigorously and running head first towards the sea, a bit like an aeroplane. In fact, on the island of Midway, some of the albatrosses have started using disused runways as runways. If it works, it works. But it is a shame that we don't have them. But there are albatross sightings in the UK, like those black-browed albatrosses that come in as vagrants and stay for a long time, but it's not enough to really make a population or a colony. But other kinds of seabirds did live in the North Atlantic until more recently, but they also died. In the Canary Islands and the Azores Islands, where you find a bunch of now extinct seabirds. You have the dune shearwater and the lava shearwater, which lived in the Canary Islands. They would not have been that different from shearwaters we'd see today, but there are marked differences in the bones of these birds that do mark them as different from other shearwaters. So they were doing something different, and they were probably distinct in some way. If they were alive, we probably couldn't tell, because it's really difficult to tell all shearwaters apart from each other. And we also have this petrel, the Pterodroma zynodorum. It doesn't have a common name yet, but this one lived in the Azores. What is common in these three birds is that they all become extinct relatively recently, often after the arrival of people. And it's caused by hunting them for meat. In fact, if you go to places like New Zealand, they actually, you will gladly say that the meat of shearwaters, especially young shearwaters, which they call mutton birds, are quite good tasting, and they are easy to collect because they burrow under the ground. And they don't exactly have good defenses. So you can just grab one from the burrow. Which is also not good if suddenly rats, cats, or dogs arrive, which will gladly feast on the eggs and chicks of these birds. So so they do become extinct, unfortunately, quite quickly. And after a sip of water, we'll get to the main star retraction. There. And now we move on to the great auk, which again became extinct only recently, and was a fully unique exhibit to the North Atlantic. It's called the great auk today, but it's been also known by many other names, such as the gyrofowl and the penguin, and other names of that nature. Now, penguin is interesting because and also true, you can actually find in the journals of seafarers and men who went out to kill these birds in Canada, who referred to them as penguins. In fact, in French, this bird is called the grand penguin. Then again, the term penguin in French is reserved for auks and gilly. The name for penguins in French is different. And they call penguins with the term monstrous, and this bird in French would be le grand pingouin, the grand penguin. And it's about 80 centimeters long in life, so quite a bit larger than this, and 5 kilometers in weight. Because when you're flightless, you can be big. You don't have to be a hollow bone. You can actually build both fat and muscle quite quickly. And as previously mentioned, it was the only flightless seabird in the North Atlantic. And unfortunately for the people us living today, it became extinct in 1844, or due to a number of reasons where we'll get into shortly. But here's some reconstruction. Here's some paintings of them. And here's a drawing of an adult and a chick by David Quinn. Pearson has painted this portrait of great auks in their natural environment, the ocean, which is where they was home. And here is the egg of the great auk, which would be about the size of my hand. The guillemots and auks lay large eggs, and it's not only natural that the largest auk lay quite large eggs. But everything comes from somewhere. Species evolve and go extinct all the time, but they evolve for a reason, which is why. And the reason is that something makes them better at survival than others of a similar nature. So a few words on the evolution of the great auk. Great auks first appear about 5 million years ago. At least the first great auk fossils are 5 million years old, and those would be in the genus Penguinus. The species in question is already large and flightless, so we know that about 5 million years ago there was something like the great auk already. We don't have a transitional fossil yet of something that was like a great auk but could fly, but we could guess that it resembled its closest relative of the razorbill. And you can imagine razorbills becoming larger and larger and having shorter and shorter wings. And because we find great auks flightless 5 million years ago, they must have become both flightless, penguin-like, and larger Leon. But why wouldn't it evolve to be flightless? Well, flying is a lot of work. You have to flap your wings quite a bit, which is a great effort in people. It's a great big effort in birds as well. And auks, which can both swim and fly, have a bit of a problem. If they become better at swimming with their wings in the water, they'll be worse at flying. But if they become better at flying, they become worse at swimming with their wings. They are always on a balancing act of a kind. And for a great auk, the answer was, well, if I can not fly, I can become as good of a swimmer as I can. But it was not the only thing driving flightlessness, because evolution is also shaped by the environment. Flightlessness in birds often evolves when you don't have to fly, which means that there is no reason to get into the air to start with. If there is no reason to get into the air to start with, birds usually don't fly. And in this case, it's because there were islands out in the sea which had no connection to land. There were no land predators. Birds could just stay there and become better swimmers because nothing was catching them that would force them to take flight. Such a thing happened with great auks, but it also became a bit of a problem, because if you have evolved in an environment with no land predators, you don't exactly fear anything, especially when something strange, it comes along wobbling on your island and carries a big stick and is about to whack you in the face with it. But it is a successful strategy nonetheless, because it has evolved about 4 times in Zatli. It's like in here, you see, here's the great auk, here's a penguin. Penguins actually evolved about 60 million years ago and became flightless and big already at that time. So they got there first. And we also have this lovely fellow. It's a Pletopterid, which lived in the North Pacific. It looks a lot like a penguin, but it's in fact related to gannet. It's an interesting case of convergent evolution, which is where animals with different evolutionary origins evolve to be similar because they have similar environmental pressures. Another good example is this lovely fellow. It's called a mancallin, or a Lucas auk. It's a kind of auk-like bird. It's related to auks, but it has no close living relatives, and they become flightless. And they evolve to be flightless as well. But they don't live in the North Atlantic. They lived in the North Pacific. So you have 2 cases of auks becoming flightless. So must have been a winning strategy. It's still working out in the southern hemisphere, but a bit different in the northern hemisphere, unfortunately. Which begs the question: why did the great auk go extinct to start with? Well, there are multiple causes. Most of them are causes that were made by peoples and our relentless hunt for the bird. In fact, the primary reason for the bird to go extinct to start with was humans hunting them for their meat and their oil and their down, which is the main reason people started to hunt them, along with collecting eggs, both for consumption and by researchers. Back in the day, everyone who wanted to make a name for themselves had an egg collection. It's a bit different from collecting sport cars or racehorses or stamps, but that was the times, I would guess. We don't know if invasive species were a problem, but if you who introduced dogs, rats, or cats to an island which didn't have them before, or the results are rarely good for the birds. Specimen collecting also became a problem later on when the bird was becoming very rare in the 1800s. When you would expect that people would come in and rally to save the bird and stop killing them altogether and leave them alone. Well, a bit different back in the day. Back then, scientists would send letters to people saying, "Hey, you have this rare bird. Could you kill a couple and send them over for me to be stuffed?" It only made the problem worse as the bird became rarer and rarer. And when a population becomes smaller in a species, random events that in normal circumstances wouldn't affect a population in any way long term become problems. One example is volcanism, and we'll get to that we'll get to that shortly. And all we have now are bones and eggs and preserved specimens of the grey and contemporary art, of course. But we can never see a grey Etorca lab again. Here is this specimen. In fact, is in I think it's in either Edinburgh or Glasgow, in the National Museum alongside its egg. This is a Paleolithic artwork from Portugal, made by people who probably hunted and sustained themselves on the oak on occasion. And here's a range map of the bird based on both historical records and bone records. The little dots are colonies of the bird which were destroyed one by one. There's a couple of them in Canada, there's one in Greenland, a couple in Iceland, one in the Faroe Islands, one off St. Kilda, and one in the outer islands of the Orkneys. and it starts early. It starts early on. During the last ice age, they were found in Iberia and the Mediterranean. During Roman times, you could see one in Amsterdam. During the 1700s, they were only found in a couple of islands that were quite difficult to reach, and continuing on, only got worse. A brief timeline on the last auks. The most famous and largest colony of great auks, Funk Island, which is in Newfoundland, Canada, was fully destroyed in 1800 after aggressive overslaughter of the birds for their down, their oil, and their meat. The last auk of the Orkney Islands was promptly shot in 1830. Which is especially sad because the Orkney Islands were home to one of the great colonies of the great auks, and it was commemorated with this statue that itself became extinct after a particularly violent storm blew its head off. The last colony of the great auks that we know of was Geirfuglasker in Iceland. Its name means Geirfell or Great Auk Rock, but during a volcanic eruption, the entire island sank down under the surface of the ocean, which not a good thing to happen for a colony of great auks, which had to flee the island, and they scattered all of the winds. And doesn't sound like a big thing again, but if a population is slow enough, which at this point it particularly was, but knowing that it's the last colony, random events such as this can have big effects, especially when this particular rock was inaccessible by boat. Now, after 10 years, the last rock of the UK was killed in St Kilda in 1840. Here's a drawing of what could have happened. It was beaten. It was taken by local people and kept in a hut until a big storm came in, and they decided to beat it to death with a stick and a rock because they thought it had called up the storm, and they thought it was a witch. Things happen, and the very last auks ever to live on this earth were killed on Edley, Iceland, in 1844. Remember Geirfuglasker, which went down on a decade earlier? That was inaccessible by boat. Edley was accessible by boat, and the great originally there were 50 great auks on Edley. And they were killed one by one. The last two were killed to send them to a collector who had commissioned them to be stuffed. And their egg was squashed under the boot of the person who killed them. And that is the end of the great auk, as commemorated in this Walton Ford painting entitled Funk Island, the great auks marching one by one into the fire of human consumption. And they might have gone off easy because seabirds are still in big trouble. There's a growing number of causes that threaten the survival of marine birds of the North Atlantic and beyond. One of them is plastic pollution. That's a gannet with a nest made of fishing nets. Which is not a good idea if you get tangled in your nest material and then get strangled and die, which can happen. There's also the problem of overfishing. Many birds have trouble finding enough food to sustain their young, especially in areas that are heavily overfished, like the waters around the UK and the EU. There's also pollution, and again, random events are a big deal, especially like oil spills. You can have an oil spill if it happens around a big colony of birds. where the birds are in big trouble, especially when an oil gets stuck up into their feathers, makes it hard for them, and goes through their feathers and gives them hypothermia because it removes the protection the feathers give them from the cold. Not to mention the amount of pollution and oil and plastic that they eat because we keep dumping it into the ocean. There's also death as bycatch because sometimes birds get tangled in nets, or they catch a longline in bait because they think it's a fish. And these accidents keep on happening and happening and happening. And then there's just random events that just happen for no reason, like big storms that can kill seabirds as they are battered. And due to climate change, storms are getting stronger and more frequent. And if birds die, and if a storm is strong enough to kill birds, not good. And you can see why seabirds are in trouble. They are killed by 1,000 paper cuts, and efforts to protect them should be as widespread as these causes are. So, not a positive note to end on, but that's how it goes sometimes, unfortunately. I'd like to give special thanks to the Orkney Science Festival, my supervisor Juha Saarinen, the Björn Kurtén Club, Tim Burkhead and colleagues who made this recent book on the grey hawk. I think it's still available in bookstore. Also, get one while you can. I'd also like to thank Errol Fuller, who made this enormous monograph on the great hawk, which lists all the specimens and all the eggs that we still have left of the bird, which is quite interesting. And also Howie Firth, who visited Finland last year to commemorate the death of paleontologist Björn Kurtén. I pitched this talk. I have a talk at the Orkney Science Festival for him, and he didn't say no. So glad I can. So only to thank him for letting me in. And this talk is dedicated to the memory of paleontologist Björn Kurtén, Finland's chief paleontologist, a professor, an author, a popularizer of science and natural history. The Paleontological Society's Björn Kurtén Club celebrates his legacy, and thanks to him, the University of Helsinki actually studies paleontology. I couldn't be here if he wasn't there. And this is the end. Thank you very much.
Thank you very much for that, Ilari. That was a really interesting talk about the evolution of seabird in general. And I'm sure there'll be tons and tons of questions, and we've only got 5 minutes or so. But if you've got a question, just stick your hand up, and Giorgio will run up to you. Somebody at the back there, I'm afraid. Yeah. And pass the microphone over to you to get your questions answered.
Hello, Andrew Appleby. I have a photograph on my computer of some grooved ware Neolithic pottery from Skara Brae, which Sigrid, my wife here, actually noticed and recognised. We were in the stores of the National Museum looking through the Neolithic pottery from Skara Brae, and there, lo and behold, was a great Auks head on this shard of pottery. Errol Fuller saw the photograph and really regretted that it had already published his big tome, because he said it can be nothing else other than the great hawk. I'd like to show it to you later. And he said the earliest picture of a great hawk was your Paleolithic one from Portugal. And the next one was really 17th century, and there's nothing in between. So if you care to look at this, there's another bird on the sherd as well, which is a dunter duck, identified by Eric Meek. There you go. Thanks. Well, it may suggest that there was a colony of great auks actually at Skara Brae. There were in the loch that was in front of Skara Brae. It would be an ideal breeding place. There you go.
Yeah. Thank you very much for your note. I'll look forward to talking to you about this piece of pottery. I'll remember to take photographs of it, and actually you go and see it if possible.
Because they don't believe it. And archaeologists can't see it.
Well, damn it. But
it's terrible.
Well.
It's a great awe.
Well,
You can have my paper.
yeah, I'll be glad to talk to you after this presentation. And you do make great points about possible breeding grounds of the Orkney. They're certainly possible. Well, unfortunately, we'll need to find bones of the animal in the Orkneys to confirm it. But it's entirely plausible. They would have bred and grown in places and even molted in places that would have been safe, like the loch. Yeah. Anyone else?
Yeah, I'm just interested, what makes a good clay for preserving fossils?
Okay, if you want to become a fossil, first you must die, but you'll need to make sure that your bones are preserved in very special places. They need to be covered in sediment quickly enough that predators or scavengers or bacteria won't get to you and start eating in your flesh, and but also slowly enough not to destroy your remains, and you also need to be deposited in a special place. Best places to do so are in places where there's slow deposition, like in river deltas or in shallow ocean or ocean shallows or in lakes, and then all you need to do is hope that geological forces don't destroy what's left of you. Certain animals do have an unfair advantage in fossil preservation. These are marine invertebrates because they have tough shells, and they're often deposited in shallow water to environments where they're covered quickly and they preserve well. Animals with big tough bones are also examples. Examples of which would include large mammals like elephants or whales, also giraffe, so their relatives, even the likes of dinosaurs and marine reptiles. It's especially hard if you're small, you have hollow bones, and crucially you have no teeth, because teeth are the hardest part of a mammal's body, and they're most likely to preserve in the long run. And birds are small, they have hollow bones which help them fly, and again are part of their breathing apparatus, because parts of their lung tissue, their air sacs, actually spread into the bones. Ow! And they have no teeth. So.
Last question from Lady.
I just have a small question. How many eggs still exist in museums? Do you have any idea?
I don't know the exact number off the top of my head. I should ask Errol Fuller, but he's not here.
My second question would be, I think they have different patterns on them. Do you know why that would happen from an evolutionary point of view? Is it so the individual parents could identify their eggs, or were individual eggs from each individual the same or different?
It could be part of it, but a part of why the eggs of great auks are all different is because of how the egg is formed inside the body of the mother. first you have the yolk develops, which is basically food for the little embryo inside. Then it passes down through the oviduct of the mother, and it's surrounded by the white of the egg and the amniotic membrane. Finally, the shell is formed, and before the bird lays its egg, it spins around inside of her, and little cells inside her oviduct apply pigment to the surface of the egg as it spins and moves around in her body. Which is random. It's a random thing. It's observed in birds which have similar egg patterns today, like guillemots and avocets. It's
Excellent description. Thank you.
Well, thanks very much.
Yeah.
We have some excellent presentation this afternoon and fascinating insight into
Yeah.
work.
Yeah. If you have any more questions, I'll be up there.
Yeah. The coffee room back after.